Hello and what's up guys? In this video, we will be repairing this inverter welding machine with flux core welding function. You can see that this is very clean and almost brand new. That tells you the bad quality of these cheap machines because they break down just after a few use. It has a terminal to connect a MIG welding torch in addition to the regular positive and negative terminals for MMA or stick welding. The owner of this machine attempted to do repairs by himself, with the wires going to the power switch. He said that the machine will shut down intermittently and he thought it is loose wiring connections. But now it will not power up at all. When I tried to turn it on the first time, the circuit breaker in my room tripped. The reason is that some of these cheap welders do not have the soft start circuit. Upon turning on, the initial charging of the big capacitors draws a lot of current and it resembles a short circuit.
Nag-brown out.
I am using this light bulb I got from an old microwave oven to quickly discharge the capacitors to prevent electric shock. You can see that I connected a 220 volts electric bulb in series with the AC power plug. That will be my makeshift soft start circuit to stop my circuit breaker from tripping. I will later make it into a proper fixture.
20 volts.
Now, as with the usual troubleshooting, I will be testing the power supply starting with the 320 volts DC. I tested it from the terminals of the big electrolytic capacitors and I do get 320 volts. I then test if there is 320 volts going to the auxiliary power supply. To my surprise, the fan momentarily works when my test probe is touching the pins. But later, when I probe it once more, I am not getting 320 volts. So the condition is intermittent as the owner has said. The pin of this header should be connected to the 320 volts DC. I am now using the continuity test function of the multimeter and we can see that it is not electrically connected. I temporarily removed this capacitor just to show you the PCB trace that leads to the 320 volts DC. This small PCB is the auxiliary power supply module for this unit. If there is no 320 volts DC going to that board, then the auxiliary power supply will not work, and so is the whole welding machine. I now test the continuity from this side of the board just to confirm. You can see that by using the continuity test of the multimeter, it appears that the negative 320 volts DC is not connected to the auxiliary power supply board. This is the case of cracked solder joints. One of the reasons of cracked solder joint is excessive heating of the PCB traces and pads. Most common repair is to simply heat and reflow the solder in the PCB. In hindsight, I should have soldered a separate jumper wires connecting the pin directly to the capacitor. That should make a lot better connection. Now let's see if that works. When I turn it on this time, the fan works immediately. With the multimeter, we can see that we are now getting 320 volts to the auxiliary power supply module, as well as the 24 volts and 15 volts output of the auxiliary power supply. Just a reminder that the negative 320 volts DC is not connected to the ground plane off the low voltage circuit of the inverter welder. Now that the power supply is working, we can almost assure that this welder is now working normally. There is a push button function selector in the front panel, and when I select to MMA function, we can see that there is about 55 volts DC in the terminals. When I selected the MIG function, there is no output voltage because that is to be turned on by the trigger switch at the torch. I will mimic the trigger switch by touching the leads with the screwdriver. And you can see that the output does turn on, and also the wire feeder motor rotates. Now I will show you the fixture I used when working with inverter welding machines repairs. This is a 100 watt 220 volts light bulb connected in series to the AC line. So for example, you have a short circuit connected to this outlet, like this plug right here, that I use for testing. The bulb will just light up brightly, but it will not trip the house circuit breaker. The switch right here will bypass the light bulb in order to deliver normal power to the device that is plugged in, only once it is confirmed that there is no short circuit. Here is the circuit diagram of the fixture, and together with a photo of the other one that I have. I tried using both the MMA or stick welding function and the flux core arc welding using the MIG torch, and they both works fine. The next machine is of a different brand name, but the fault is very similar to the first one. You can see here, same with the first one, the owner tried to fix the AC cord connectors. Just by visual inspection, we can already see that there is something wrong with the board. This copper trace of the PCB is completely peeled off. It will only happen due to excessive heat. Before I remove the board, I check the power switch with the continuity tester, and you can see that one of the poles is not working. This is very common fault with this cheap machine, and the switch should simply be replaced. So the copper trace coming from the 320 volts DC positive has peeled off. And at the bottom, we can see that the 320 volts DC negative is the same situation. I did a board repair by connecting a jumper wire to replace the broken PCB copper traces, and that simple repair together with replacing the on-off switch fixed the problem with this machine. We are now getting 320 volts DC input to the auxiliary power supply and the 15 volts and 24 volts DC outputs. On the front panel, the output of the welder is about 50 volts, which is normal. And finally, I tested it for both MMA and flux core welding using MIG torch, and everything is okay now. I hope that you enjoyed and learned something with my videos, and if you do, please hit the like button and consider subscribing and following me on Facebook. Thank you very much for watching, and God bless you all.